A hypothesis is a statement regarding a characteristic of one or more populations. So here's some statements that could be made. According to the time use survey, the mean amount of time employed male Americans spend working on weekends is 5.46 hours. A researcher wonders if males employed part-time work more hours on average on weekends. Another example. Harris Interactive reports that 55% of adult Americans aged 18 or over prefer purchasing name brand coffee over generic brands. A marketing manager with Starbucks wonders if the percentage of seniors who prefer name brand coffee differs from that of all adult Americans. Or a third scenario, using an old manufacturing process, the standard deviation amount of wine put in a bottle was 0.23 ounce. With new equipment, the quality control manager believes the standard deviation has decreased. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. So this is the formal method. Make a statement regarding the nature of the population, collect evidence, which is your sample data, to test that statement, and then third, analyze data to assess the plausibility of the statement. And so with this hypothesis testing, we're going to have two different statements that are involved in the process. The first is called the null hypothesis, and the null hypothesis is denoted with an H with a subscript 0. We read that H naught. That is the statement to be tested. The null hypothesis is always a statement of no change, no effect, or no difference, and is assumed true until the evidence indicates otherwise. And then there's an alternative hypothesis denoted H sub 1. That is the statement we are trying to find evidence to support. And so in the example that we started with, the null hypothesis would have been, yeah, the coin is fair. And the alternative hypothesis is, no, the coin is not fair. The null hypothesis we assumed is a fair, right? We assumed we had a fair coin, so that's why that was the null hypothesis. And then you were weighing your sample evidence against that in judgment of determining whether the alternative hypothesis, the coin is not fair, may be the more reasonable explanation. So in this chapter, we're going to set up the null and alternative hypothesis in one of three ways. We're going to change this each time we introduce a new method, but for this chapter, it's one of these three ways. You're going to have what's called an equal versus not equal hypothesis. Oftentimes, I'm going to refer to that as a two-tailed test. That's where the null hypothesis is that the parameter equals some value, and the alternative is that the parameter is not equal to or different from some value. We're going to have a left-tailed test, which is equal versus less than. There, the null hypothesis is the parameter equals some value, and the alternative is the parameter is less than some value. And then we have a right-tailed test, which is equal versus greater than. In the equal versus greater than, we have the null is that the parameter equals some value, and the alternative is that the parameter is greater than some value. So what we're going to do now is form these hypotheses using those three scenarios that I just laid out for you a few seconds ago. So for each of these scenarios, we're going to determine the null and alternative hypothesis, and then state whether the hypothesis is two-tailed, left-tailed, or right-tailed. So according to the American Time Use Survey, the mean amount of time employed male Americans spend working on weekends is 5.46 hours. A researcher wonders if males employed part-time work more hours on average on the weekends. So when you're doing these hypothesis tests in this chapter, the first thing you're going to want to do is identify the parameter of interest. What's the parameter of interest in this particular problem?
Hours worked.
Well, that's the variable of interest, is hours
Okay.
worked. So when I say parameter, that would be like the population proportion, the
people.
population mean, a population standard deviation, like that.
So the amount
So-
of time employed by male Americans,
Yeah, so what parameter is that?
that would be the population mean. What is that?
Yep, population mean. It's right there at population mean, right? And so that tells you right out of the gate that this is how your null and alternative hypothesis are going to be structured, because mu is your population mean. We said P is your population proportion. And then we have sigma, that could be a population standard deviation. So in this particular problem, we have our parameter of interest is the population mean. Remember, the null hypothesis is always a statement of no change, no effect, no difference, meaning there is no difference between the amount of time employed male Americans spend working on the weekends and those who work part-time. What would be the mean amount of hours we'd assume part-time workers are employed on the weekends?
5.46.
Yep. We're going to assume the mean amount of time they spend working on the weekend is 5.46 hours. And then the alternative hypothesis is the statement we're trying to gather evidence to demonstrate. We want to know if the part-time workers are working more hours on the weekends. And so what you have to do is read that language and judge what direction your alternative hypothesis is. Is it a not equal to, which would mean like different? Or is it a greater than, which would say things like more than, exceeds, something like that? Or is it a less than?
So more than.
Yeah, so this is a greater than inequality, 5.46 hours, like that. And so you can see this is a right-tailed test. Now you can write these in words as well if you want. So this is the null hypothesis is the mean amount of time employed part-time workers work on the weekend is 5.46 hours. And then your alternative hypothesis is the mean amount of time employed part-time workers work on the weekend is greater than 5.46 hours. So on the left, we have the formal symbolic way to represent the null and alternative hypothesis, and then the words on the right represent it just using plain old English. So now let's look at letter B. Harris Interactive reports 55% of adult Americans aged 18 or over prefer purchasing name brand coffee over the generic brands. A marketing manager with Starbucks wonders if the percentage of seniors who prefer name brand coffee differs from that of all adult Americans. So again, we're going to determine the null and alternative hypothesis. What is the parameter of interest here?
Adult Americans aged 18 or over.
Well, that's the population
That
of
population.
interest. That's not the parameter, though.
This would be proportion.
This would be a proportion. And you can think about it this way. When we're asking, do you prefer name brand over generic or not? So you either have the characteristic that you prefer name brand or you don't, right? And so that's a qualitative variable, which has two possibilities. Either you prefer it or you don't. So that tells you in some regard, hey, this has got to be a proportion. Plus the fact that we're giving you the fact that 55% of adults have that characteristic.
Mhm.
And so if that's the case, what's the statement of no change, no effect, no difference? If there's no difference, we want to know, is there a difference between seniors and adult Americans in general? So if there is no difference, the statement of no change, no effect, no difference would be the proportion of seniors who prefer name brand coffee over generic is 0.55. That's the statement of no change, no effect, no difference between seniors and the general adult American population. And we would symbolically write that P equals 0.55. And
So
then
we,
what are we trying to gather evidence to show? Well, we're trying to see wonders if the percentage of seniors differs from adult Americans. And differs would imply what kind of hypothesis test among these three?
the two-tailed.
Yeah, the two-tailed, because we're not saying whether it's higher or lower, just that it's different. And so that would mean that P is different from 0.55. So in words, we would write that the proportion of seniors who prefer name brand over generic differs from 0.55. So now if you read these, let's go back and reread these again. In the first one, we're saying the mean amount of time employed males spend working on the weekends is 5.46. We're just stating a fact.
Right.
And then the second sentence says, hey, I wonder if employed part-time males work more than that on the weekends. So the null is always a statement of no change, no effect, no difference. There is no difference between all employed males and those that are employed working on the weekends part-time. No difference between them. And so that's what your null hypothesis is that the mean of these employed part-time workers is also 5.46 hours.
Which is the first sentence for
Which
these
is
both?
the first sentence, right?
Okay.
Always a statement of no change, no effect, no difference between the two groups you're comparing.
Right.
And then the second sentence is your research statement, your research hypothesis. That's what you're trying to gather evidence to show. Do part-time employed workers work more than that on average on the weekends? And the more than or greater than implies a greater than inequality.
Okay. So the second sentence is kind of disputing the first in a way.
Dispute's probably too strong of a word. It's just a sentence where it's the goal of our research.
Okay. Gotcha.
Okay. And so if we use that kind of thinking with letter B, Harris Interactive reports 55% of adult Americans prefer name brand over generic. Starbucks wonders if the percentage of seniors prefer name brand differs from that.
Right.
So the statement of no change, no effect, no difference is there's no difference between adult Americans and seniors. So seniors are also going to prefer name brand at a clip of 55%. That's your null hypothesis. And then your goal of the research is to see if seniors differ from all adult Americans. And the phrase differ implies different, implies a not equal to alternative. So to make sure that we're on the same page, let's try this last one. Using an old manufacturing process, the standard deviation amount of wine put in a bottle is 0.23 ounce. With new equipment, the quality control manager believes the standard deviation has decreased. So what's the parameter in this particular scenario?
That would be proportion.
So standard deviation.
Yeah. We're wondering about the standard deviation amount of wine. So even though this is a decimal, it doesn't automatically imply proportion. Because if you think about the variable that we're measuring here, it's the amount of wine, which is a quantitative continuous variable. And so that right out of the gate suggests there's no way that this can be a proportion.
Okay.
Okay. And so we're wondering about the standard deviation. And now we have to come up with a statement of no change, no effect, no difference, meaning there's no difference between the standard deviation amount of wine with the old process and the standard deviation amount of wine with the new process. If there's no difference, then the standard deviation amount of wine is going to be how much?
Wait, with no difference?
With no difference.
0.23.
Yep, 0.23 ounces. And what do we want to know?
If it's less than?
Yeah, if it's decreased. So is it less than 0.23 ounces? So again, in words, this first sentence is saying there is no difference between the old and new process. And the alternative hypothesis saying the new process results in a lower standard deviation. And you could imagine in manufacturing, if you have a lot of variability in your bottles, you have some people that are getting too much wine, some people that are not getting enough wine.
Okay, so real quick, we can measure, we're looking to measure either population proportion, population mean, or standard deviation then?
For these three, yes. That was all three possibilities, right?